Hi, my name is Shami Farah Amani.
Hi, my name is Nurin Shahira binti Zulfitri.
Assalamualaikum and hi everyone, my name is Rizky Adika.
Assalamualaikum and hi everyone. My name is Alia Batusha binti Azharuddin.
Now, let's solve a matrix by using Gaussian elimination method. Equation 1 equals to x plus 2y plus 3z plus w plus v equals 20. Equation 2, 2x plus 3y plus z plus 2w plus 3v equals to 25. Equation 3, 3x plus y plus 2z plus 3w plus 4v equals to 30. Equation 4, 4x plus 4y plus 4z plus 4w plus 4v equals to 40. And equation 5, 5x plus 3y plus 2z plus w plus v equals to 35. From the equation, we will got matrix A equals to 1, 2, 3, 1, 1, 2, 3, 1, 2, 3, 3, 1, 2, 3, 4, 4, 4, 4, 4, 4, and lastly 5, 3, 2, 1, 1. And then matrix V equals to 20, 25, 30, 40, and 25. Then we have to augment matrix A with matrix V, which we will got 1, 2, 3, 1, 1, 20, 2, 3, 1, 2, 3, 25, 3, 1, 2, 3, 4, 30, 4, 4, 4, 4, 4, 40, and 5, 3, 2, 1, 1, 25. And then we have to reduce it to the row echelon form. Subtract 2 times row 1 from row 2, which is row 2 equals to row 2 minus 2 times row 1. And then subtract 3 times row 1 from row 3, which is row 3 equals to row 3 minus 3 times row 1. Then subtract 4 times row 1 from row 4. Row 4 equals to row 4 minus 4 times row 1. Subtract 5 times row 1 from row 5. Row 5 equals to row 5 minus 5 times row 1. And then subtract 5 times row 2 from row 3. Row 3 equals to row 3 minus 5 times. Then subtract 4 times row 2 from row 4. Row 4 equals row 4 minus 4 times row 2. Then subtract 7 times row 2 from row 5. Row 5 equals to row 5 minus 7 times row 2. Then subtract 2 over 3 times row 3 from row 4. Row 4 minus 2 over 3 times row 3. And then we have to subtract 11 over 9 times row 3 from row 5, which will be row 5 equals to row 5 minus 11 over 9 times row 3. And then swap rows 4 and 5, and then we can extract equations from the matrix. x1 plus 2x2 plus 3x3 plus x4 plus x5 equals to 20. Row 2, negative x2 minus 5x3 plus x5 equals to negative 15. Row 3, 18x3 minus 4x5 equals to 45. Row 4, negative 4x4 minus 55 over 9x5 equals to negative 15. And lastly, row 5, negative 4 over 3x5 equals to negative 10. And we got solved for x5 equals to 15 over 2. After that, substitute values of x5 into the equations, and we will got solved for x4 equals to negative 185 over 24. Then substitute the value of x4 and x5 into the equations, and we will get the values of x3 equals to 25 over 6. Then substitute the values of x5, x4, and x3 into the equation, and we will get the value of x2, which is 5 over 3. Then substitute the value of x5, x4, x3, x2 into the equations, and we will get the answer for x1 equals to 35 over 8. And lastly, substitute all the values into the equations, and we will get x1 equals to 35 over 8, x2 equals to 5 over 3, x3 equals to 25 over 6, x4 equals to negative 185 over 24, and x5 equals to 15 over 2.
Now,
I'm going to explain how we solve a system of linear equations using the Gauss-Jordan elimination method. This method is a systematic way to reduce a system into a form where we can clearly see the solutions for each variable. We begin with a system of 5 equations with 5 unknowns, v, w, x, y, and z. We represent the system in matrix form, where the left part of the matrix contains the coefficients of the variables. The rightmost column contains the constants from each equation. This gives us an augmented matrix. Next, we apply elementary row operations to simplify the matrix. The 3 types of operations we use are row swapping, which exchanging 2 rows, row scaling, which multiplying a row by a constant, and row replacement, adding or subtracting a multiple of one row to another. The goal is to convert the matrix into row-reduced echelon form, where the diagonal has all ones and all other values in the pivot columns are 0. For example, we start by making the top left value a pivot, then eliminate values below it. We continue doing this for each row, moving down and to the right, one pivot at a time. This step-by-step process is repeated. Scale the row to make the pivot 1. Use that row to eliminate values above and below the pivot. Move on to the next row and repeat. Once all the pivots are 1 and all other values in their columns are 0, we have achieved row-reduced echelon form. This form is very useful because we can directly read off the solution for each variable. From the matrix above, the solution is clear, where x is 35/8, y equals to 5/3, z equals to 25/6, w equals to -185/24, and v equals to 15/2. This shows that the system has a unique solution, meaning the matrix is non-singular. Gauss-Jordan elimination is powerful because it gives a clear, step-by-step way to simplify large systems. It works for any size square matrix, and it helps check whether a system has no solution, one solution, or infinitely many.
I'm going to explain how to solve Cramer's rule from the matrix of 1, 2, 3, 1, 1, 2, 3, 1, 2, 3, 3, 1, 2, 3, 4, 4, 4, 4, 4, 4, 5, 3, 2, 1, 1, which equal to 20, 25, 30, 40, 35. First, we will have to find determinant of A by using cross multiplication, which we will get 96. Then, we will have to substitute 20, 25, 30, 40, 35 from the equation to each row and do cross multiplication. We will get determinant of A1 is equals to 420. Then, determinant of E2 is 160. Next, determinant of E3 is 400. Determinant of E4, negative 740, and determinant of E5 is 720. By dividing each determinant of E1, E2, E3, E4, and E5 with determinant of A, we will get the final answer, which is x is equal to 35/8, y is equals to 5/3, z is equals to 25/6, w is equals to negative 185/24, and lastly, v equals to 15/2.
Part of our video, I will be explaining how to solve a system of linear equations using the inversion methods, step by step by using Maple. We are given a system with 5 equations and 5 unknowns. In matrix form, this is written as A multiplied with x equal to b, where A is the coefficients matrix, x is the column vectors of unknowns variables, and b is the column vector of constant. To solve for x, we use the formula x equal to A inverse multiplied with b This method works only if matrix A is invertible, which means its determinant is not equal to 0. Step 1. Define matrix A. Here, we enter the matrix A into maple using the matrix commands. Each row represents one equation and each column corresponds to one variable. Since we have 5 variables, this is a 5x5 matrix. Next, we define vector B using the vector command. This column vector contains the constants on the right-hand side of each equation. Now, we find the inverse of matrix A using the matrix inverse function. If A is invertible, maple will return the full inverse matrix. Now that we have both A inverse and B, we perform matrix multiplication using the dot operator in maple. This step will give us the solution vector X, which contains the values of all 5 unknown variables. After running the command, we get this is the solution of our system. Each entry in the vector X represents the value of one variable. Thank you.
I will be explaining about homogeneous system. When every constant term in a system of linear equation is 0, the system is said to be homogeneous. This is how it appears in matrix form Ax is equals to 0. A is a matrix of coefficient, X is a column vector of variable, 0 is a zero factor which all entries are 0. Homogeneous system is divided into two categories, which is trivial and non-trivial solution. Trivial solution is a unique solution which is said rank A is equals to rank A over 0 equals to n. N is the number of columns in matrix A. From a matrix 0, 0, A slash 0, where A is not equal to 0, the coefficient matrix has a non-zero entry in every column, therefore no free variables.
And today I'm going to present about homogeneous system. This solution can be classified into two, which is non-trivial solution and trivial solution. And right now I'm going to present about non-trivial solution, or it called as many solution. A non-trivial solution is when not all variables are 0, but the equation still equals to 0. A homogeneous system has a non-trivial solution if and only if the determinant of matrix A is 0. This means the matrix is singular, not invertible, and there are free variables that lead to infinitely many solutions. The steps to solve system of linear equation is: first, write in augmented matrix form. Second, apply Gaussian elimination method, where we need to make sure the matrix is in row echelon form. Third, use back substitution. And lastly, we get the unknown equals to 0, where we need to let the unknown with any free variable. And finally, we get infinitely many non-trivial solutions.
In this slide, I will be explaining the concept of a non-homogeneous consistent system in linear algebra. What does consistent mean? A system is consistent when it has at least one solution. For a non-homogeneous system that is consistent, there are two possibilities. One is unique solution and two is infinitely many solution. For a unique solution, a system has a unique solution if the system has only one solution. All the equations are independent. The matrix is invertible. The rank condition is this, where R is the coefficient matrix and AB is the augmented matrix. Example form is this, where L unequal to 0 and B can be any real number. The next one is infinitely many solution. A system has infinitely many solutions if some equations are repeated or multiples of each other. There is one or more free variable. The rank condition is this. The example for is this, where A equal to 0 and B equal to 0. So, in summary, for a consistent non-homogeneous system, if the rank equals the number of variables, then it is unique solution. If the rank is less than the number of variables, it is infinitely many solution. Thank you.
Now, let's get to know non-homogeneous inconsistent. A non-homogeneous system of linear equations is a system where at least one equation has a non-zero constant on the right-hand side. Next, what does inconsistent mean? A system is inconsistent if it has no solution. That means the equations contradict each other. There's no possible set of values for the variables that can satisfy all the equations at once. And lastly, what is a non-homogeneous system that is inconsistent? It is a system of linear equations with non-zero constants on the right-hand side and the equations do not intersect, which means there is no solution.
Now, I will briefly explain the concept of singularity in linear algebra. What is a singular matrix? A matrix is called singular when it does not have an inverse. In technical terms, a square matrix A is singular if its determinant is 0. Or, if a matrix is singular, it means we can't solve the system of equations using the inverse method. The system may have no solution or infinitely many solutions, but not a unique one. It usually happens when rows or columns in the matrix are linearly dependent. For example, one row is just a multiple of another. Other than that, the matrix is not full rank, meaning some variables are not contributing new information.
And lastly, let's look at determinants. We use determinant to solve system of linear equation, to check if a matrix is singular or non-singular, and to find inverses of matrix. There are many ways to find determinants. The first one is formula. For 2 times 2 matrix, we can use this basic formula, which is AD minus BC. And for 3 times 3 matrix, we can use Sarah's rule, or it is known as cross multiplication. Second, we can use cofactor expansion. Expand along any row or column. Smart to pick one with the most zeros. We need to be careful with the sign pattern, with plus minus, and the formula is Aij Mij minus Aij Mij. So be careful with the sign. Third, for triangular matrix, multiply the diagonal elements to get the determinant. And fourth, row reduction method. Reduce the matrix to row echelon form. We need to apply row operation rule. For swept rows, we need to multiply determinant by -1. For multiply a row, we need to multiply determinant by that scalar. For add or subtract rows, no effect on determinant. Now we move on to application of determinants. First, find inverse using adjoint method. The formula is A inverse equals to 1 over determinant of A times adjoint of A. The step is find cofactor matrix. Second, find adjoint, which is transpose of cofactor matrix. And third, substitute into the formula. The second application is solve system using Cramer's rule. The condition is matrix must be squared and determinant of A is not equals to 0. And lastly, system must be linear, where variables to the power of 1. In conclusion, we explored key methods to solve linear system, which is Gaussian elimination, Gauss-Jordan elimination method, Cramer's rule, and the inversion method by using mapper. We also explained important concepts like singularity, homogeneous and non-homogeneous system, consistency, and also determinants. This gave us a solid understanding of both the computation and theory behind linear algebra. That's all from us. Thank you.